Good afternoon, everyone. I am Ruggero Poletto, and I welcome all of you to this CFD webinar about Multiphase App we developed inside the simulation platform of Conself. In this webinar, which is part of an update we are doing considering the release we made during the springtime, and so we are updating all the customers and the users in general about the new software capabilities. We did a webinar about the new Noshape integration that was last week. Then there is this one, and there is the last webinar before the summer break next week about buildings simulation. As many of you may already know, Conself is a new company which started in April 2015. We are Italian. We have a headquarters in Milan next to the airport, and we have our present and operative locations all over the country. At the same time, we developed in the latest year a network of distributors and commercial partners all over the world, such as North America, South America, and Asia. In here, you can see an overview of the worldwide concept distribution. So take advantage of it. If you are in any of these countries, please contact our distributors. Today, we're gonna talk about Conself service, in particular the simulation platform, which is available to all the users directly from your browser. In fact, with Conself, all the engineers can take full advantage of cloud technologies. We give them the capabilities to do mechanical and fluid dynamic simulations directly from the browser. So we don't need to install anything on their local machine. At the same time, we take advantage of cloud computing, and so it is possible using our simulation platform to use the remote hardware resources we give available to all the users. At the same time, we have a dedicated cloud computing service that allows users to run simulations and run their own software, install it and everything directly by themselves. We give them access either via remote desktop or via SSH connection. We have a wide range of operative systems available and a wide range of software, so I invite you to visit the web page of the service. Last but not least, obviously, we also offer an engineering consulting service in which our experts use our technologies, our best technologies, in order to help customers improving their products design, improving engineerization, etc. The heart of today's webinar, the core of today's webinar, is a simulation of a simple tank. In this tank, we are injecting a mixture of air and water, so two incompressible fluids and totally unmiscible, and we are checking out how they work and how they fill the tank and how they go towards the outlet of the domain. During this simulation, we're going to take advantage of Conself simulation platform. So feel free to register at the end of the webinar or make questions about future developments and current capabilities. So we switch now and we move to the simulation platform. Here I am. I am on a normal browser. I run Ubuntu 14.04 and the browser I'm using is Google Chrome. So quite a common configuration, but at the same time, we can guarantee that our service works on any operating system and on any browser. Directly from the browser, I just type login and I am suddenly forwarded towards the login page of the Conself web application. It takes a few seconds, on which I need to input my user and password. Obviously, for new user, it is possible to register for free. So I just log into the application. And in few seconds, here I am. I am now in the application. So this is a complete simulation tool you have available directly from your browser. If you go to the Simulations tab, it is possible to start a new simulation. Before creating the new case, we need to pick the environment we want to use, the application we want to use, which obviously is, as I said, is the multi-phase flow. So we call it WebEng, and we start it. Conself guides you step by step towards a complete simulation setup. There is, first of all, a geometry step, then there is a meshing phase, a CFD one, and a results phase. So once we have completed all these steps, we will be able to see the results of the current simulation. First of all, we upload the CAD. As we said before, we have a Noshape integration. So if you use Noshape, just press this button. Otherwise, you can upload any step file or IGES file or STL file from any other CAD you may install in your local machine. So this is the domain we see before. As I said, there is an inlet. It is divided into two parts because in one of them there is just the entrance of the air, and in the other part there is the entrance of the water. So I just create the boundary and input air. I just said that is the input air. The bottom one is the input water. And then obviously there is an outlet down here at the bottom. It's outlet. All the rest is the same boundary. It's a wall. So I just select all of them and I create the wall boundary. I need to decide whether the drawing has been created either in millimeters or in centimeters or in any other units. This one has been made in millimeters, and it's an internal flow as the flow is inside of the domain. So we submit the process. While the process runs in background, it is possible to know its current state, which is prepared, and the progress, which for the moment obviously is 0%, but step by step is going to reach 100%. While the process runs in its background, you can obviously turn off even your internet connection, so you can move to any other task you have to do or do anything else you like. So it's fine because we are using remote hardware, and it is possible also at this point to note also the plans Conself have available. In fact, for every hour of remote server we are using, it is possible to use one single credit. So one single credit is 1 hour of the remote server. So according to the plan you buy a certain number of credits, and thus a certain number of hours you can use on the remote server. As we have just seen, it is possible now to run the CFD simulation and move on to the Mesh 2D phase. At the top right, there is this button, the step completed. It's a summary of the completed step with messages given by the code and the software in order to promote and help and guide the users towards the best simulation. So we just have now to define the wall refinement we want to apply to all the boundaries. In this phase, we are creating we are determining the size of the triangles, which for the purpose of the current simulation is just 1 centimeter, so 0.01 meters. So step by step, I fix all the boundaries. Here they are. Submit. I am. So here it is. We gave a value of the triangularization to all the boundary, and once again, the process runs in background. It will take a few moments to finish, and probably we're going to be able to run the whole webinar live, so you can actually experience also the software capabilities. I just want to introduce you the concept manual while the process runs in background. In here you have access to all the webinars we did earlier about all the capabilities of the software and the several applications available at different levels. And obviously it is a manual, so there is a full descriptions of everything that can be done in the software, such as applications and so on and so forth. I invite you for a more clear understanding of what's going to happen right now to have a quick look at the mesh of the 3D mesh typologies we have available. We have a tetrahedral mesh made of triangles, basically. We have an hexahedral mesh made of cubes, and then obviously we have different type of wall refinements according to the tetrahedral or hexahedral. So we move back to the application and we see that the mesh 2D phase is over. So we can just open the here it is. So now we see all the triangularization. We move on with the tetrahedral mesh, which is the best for the current simulation. And once again, in here we can specify the boundary treatment, which is the boundary layer. So the number of cells extruded from the wall in order to better reproduce the boundary layer of the wall. We don't want to use it for the current simulation, so we just press apply, and we run the 3D mesh. So now, once again, the process goes in background, and meanwhile, we can have a look at the storage. In here, once it opens the page, you have a complete access to the cloud storage Conself gives you, and so it is possible to delete a case or to create new cases as well. So there is a complete overview. It's worth a while saying that currently there is no limit on the remote hardware storage Conself gives to any user. So regardless the plan you're using, you can store as many simulations as you want. And obviously, since it is a web app, we have a real-time support. So you can just send us a request of support and we'll try to satisfy as soon as possible. We move back to the simulation and the 3D mesh phase is now over. And we are now in the CFD setup. So we need to pick up the flow and turbulence model for the flows. Obviously, since in here we are simulating two different flows, we are required for both of them the density and the viscosity, the dynamic viscosity. In here, by default, you have air and just below, and water at the top. But any type of fluid, it is possible to insert for the user. We move on, and okay, we need to specify the gravity, which is minus 9.8 in vertical direction. And then we move to the boundary section. As I said, we have two different types of inlet, one for the air and one for the water. As we said, the air is the second flow, so we need a 0% of flow concentration, and the input for the water, we just apply the same boundary condition with 100% flow concentration. Then obviously there is an outlet, and we just specify the outlet pressure, and we also have a wall, which is obviously a wall no slip. Simulation setting, we have the possibility to specify the transient. So final time, 1 second, and we say solution every 10 times every second. So we can now run the simulation. No worry, the simulation runs on our server. It takes a little bit to run, but since we don't have enough time in the current tutorial, I'll open the results I did for you just before. It's this one. Time. As you can see, we are in the results part. As I just want to remember you that it is possible to post-process the results either directly online through our web application, or you can perform the post-processing just locally on your machine and just type download the results, and you download the results, and you can use either ParaView or other type of software such as StackPlot, Insight to analyze the results. But anyway, online it is possible to do quite a bit of the things you may need, such as a slice. We can pick a slice and visualize the pressure on the slice. So we just define a new scale. And obviously, it might be interesting using a stream trace, sorry, not the stream tracer, but the contour plot, in order to visualize where the fluid A actually is. So we just specify a threshold of 0.5. But for fluid, we don't want to color it. We just activate it. We just turn on the visualization, and we just give some transparency to it in order to see what's happening inside. And here it is. You can actually see the flow, which is coming from the left side. As you can see, it fills the first pipe, and then step by step it goes towards the wall and then down to the bottom of the tank. It was pretty easy to run this simulation. As you can see, I didn't need actually anything in particular. I needed to complete the simulations by myself and activate the plan, which is available also for free to all the users. Okay, with this, basically the webinar is over, and it is now your turn to make questions and to ask for suggestions. Meanwhile, I remember you the contacts we have. You can see them here, such as LinkedIn and Facebook. We are available in all the socials. And I'm also saying that on YouTube, you can see this webinar and all the future webinars we are organized, and also the previous one, the one we have already made. So feel free to also to register to our YouTube channel in order to see what are our activities. It seems that there are no questions, so I've gone quite quickly through all the webinars part, but I think this was just to give you a quick overview of the software capabilities, and obviously I invite you all to register for free and take advantage of concept simulations capabilities. Thank you all for assisting the webinar. and looking forward to our next appointment. Bye.